All right, let's just jump right into it. Because what we're looking at today is honestly a fundamental transformation in human technology. Welcome to today's Explainer, where we're going to unpack a massive shift happening right now in computing hardware architecture. Look, we are standing right at the edge of 2026, and we're about to transition from a congested, bumper-to-bumper highway of information into a completely unrestricted, light-speed superhighway of data. So get ready, because literally everything you thought you knew about processing power is about to flip on its head.
Here's our roadmap for the day. First up, hitting the thermal wall. Second, the silicon photonics breakthrough. And third, redefining AI in gaming.
So let's kick things off with Chapter 1, hitting the thermal wall. Now, you might be wondering, why is 2026 the definitive end of traditional copper? I mean, for decades, our entire digital infrastructure has relied on copper wiring to move data around, right? But as our demands for processing have just absolutely skyrocketed, that foundational material has suddenly become our biggest liability. So we really have to ask ourselves, what exactly is going wrong down there at the microscopic level? Well, the answer is heat. Traditional copper interconnects have finally hit a physical thermal wall. It's like this. When you push huge amounts of data through these metallic traces, the electrons face resistance, and, resistance generates a ton of heat. To put that into perspective, modern data centers are already spending up to 40% of their total energy consumption just trying to keep their copper-based servers cool. That's wild. As we push PC chips to their absolute physical limits, they generate so much heat that they create this severe physical bottleneck. And look, it doesn't matter how smart your software is if the hardware physically throttles and just chokes on its own temperature. We literally cannot push electrons through copper any faster without critical failures. Which brings us to a really critical crossroads. On one side, you've got our legacy tech, traditional metallic traces completely defined by heat and electron bottlenecks. It's sluggish, it runs incredibly hot, and it's holding us back. But on the flip side, we have our next evolution, silicon photonics, which uses light-speed optical pathways. We're talking about contrasting the slow, friction-heavy nature of those old metal pathways with the cool, instantaneous nature of literal lasers. And that leads us perfectly into Chapter 2, the silicon photonics breakthrough. Let's look at how this actually works in practice. Silicon photonics is all about integrating laser-etched optical components directly into everyday consumer chipsets to transmit data via light. I really want you to picture that for a second. We're no longer relying on those bulky external cables for fiber optics. Instead, engineers are laser-etching microscopic optical components right onto the silicon of the chip sitting inside of your PC. Data isn't surfing on a wave of electricity anymore, guys. It's traveling on actual beams of light right inside your computer. The magnitude of this architectural shift is absolutely incredible. To quote directly from the source material, we are, quote, ditching electron bottlenecking for light-speed data transmission. And man, electron bottlenecking just perfectly captures the whole frustration of the past decade in hardware engineering. By making this move to light, we're completely bypassing the physical resistance of metal. We're taking that traffic jam and just eliminating it entirely. By replacing those old metallic traces with high-bandwidth optical pathways, we are completely redefining our baseline for processing power. The whole hardware architecture is being transformed from the inside out. But why exactly is it so much faster? Well, unlike electricity running through a single copper wire, you can actually send multiple, completely different wavelengths of light down the exact same optical pathway simultaneously. It's a process called multiplexing. It creates this totally cool, friction-free environment that just multiplies our data capacity exponentially. All right, moving on to Chapter 3, redefining AI and gaming. So the real crucial takeaway here is how this whole hardware revolution empowers the software we actually use every day. And there are massive dual benefits here. First, we're slashing latency across complex neural networks for all the AI technologists out there. And second, we're directly reducing latency for the hardware enthusiast culture and competitive gamers. Let's break both of these absolute game changers down. On the artificial intelligence front, we're finally unlocking massive, previously unrealizable neural networks just by eliminating that bottleneck. For years now, AI development has basically been starved by the thermal wall. Think about it. You can write the most brilliant, complex neural network in the world, but if those copper chips can't move the data fast enough without totally overheating, your AI is just throttled. But with silicon photonics, these immense data streams are processed instantaneously via light. The shackles are totally off for machine learning. But hey, it's not just about enterprise-level AI up in the cloud. This tech bridges the gap straight down to your desk. For the gaming community, this means a direct, tangible reduction in optical latency. Think about highly competitive games, like Valorant, where victories is decided in literal milliseconds. High-end users and competitive gamers obviously care deeply about latency. By using these light-speed optical pathways instead of copper, the delay between your mouse click, your processor, and your screen is fundamentally minimized down to the absolute limits of physics. Talk about the ultimate competitive edge. Well, we've reached the end of our explainer for today, but I really want to leave you with this final kind of thrilling thought. For years, software developers have had to code around the physical limitations and the massive heat of copper. But now that thermal wall is finally falling. So I gotta ask you, if hardware now moves at the absolute speed of light, what will software do next? Because when the physical limits are entirely shattered like this, the boundary of human innovation becomes practically limitless. Thanks so much for joining me today, and I honestly can't wait to see what this light speed future holds for all of us.